Introduction to KUKA Robot. The KUKA robot used in this practice is KR16. The value 16 means the robot is able to carry a maximum load of 16 kg. There are many functions for the KUKA robot. A KUKA robot can pick and place, perform a repetitive operation many times, drilling holes at precise location, welding or even painting. The 6-axis of KUKA robot. Generally, the KR16 has 6 axes, which is: Axis 1, the robot base. It allows the robot to rotate 180 degrees from left to right. This is the motor that controls axis 1. This is the motor that controls axis 2. Axis 2. The joint between the base and the link arm. It is the axis powering the movement of the entire link arm. This is the motors that controls axis 3, 4, 5 and 6. Axis 3. The robot arm. It allows the robot arm to raise and lower, extending the robot's vertical reach. This section is for axis 4, 5 and 6. Axis 4 rotates the robot arm in a circular motion, moving parts between horizontal to vertical orientations. Axis 5 allows the wrist of the robot arm to tilt up and down. Axis 6 is responsible for a twisting motion, allowing it to rotate freely in a circular motion. How to start the KUKA robot. Step 1. Switch on the power supply and the pressure supply. Step 2. Switch on the automatic voltage stabilizer. Step 3. Switch on the air dehumidifier, and a loose air sound can be heard. Step 4. Adjust the effector until no sound is heard. Step 5. Switch on the computer and let it start up. This is the section that controls all the 6 motors. Step 6. Press the Acknowledge All option and the KUKA robot is ready to operate. The KUKA Control Panel, KCP. The KCP is the teach pendant for the industrial robot. It has all the control and display functions required for operating and programming the industrial robot. The labeled number are as described as follows. Number 1, the mode selector switch. The mode selector switch has 4 options to choose. Option 1 and Option 4 are used for manual operation. The difference between this option is operating speed of Option 1 is twice of Option 2. Option 2 and Option 3 are used for automatic operation. Option 3 is used only when the robot is connected to another robot using PLC. Number 2 and Number 3. The drives on and drives off. Before running KUKA robot automatically, the drives on button must be pressed first. Number 4. The emergency stop button. Whenever something unexpected happens, immediately press this button as it stops entire KUKA robot operations. Number 5 and Number 6. The space mouse and right-hand status key. Both are used for controlling the KUKA robot. The space mouse is used when the mouse icon is selected. The right-hand status key is used when plus or minus sign is selected. Number 7, 8, 9 and 10. The Enter key, arrow keys, keypad and numeric keypad. Their function is the same as the key and keypads found in a normal computer keyboard. Number 11, 17 and 18. The soft keys, left-hand status keys and menu keys. These keys are used to select the options in the panel window. Number 12, 13, 14, 15 and 16. The Start backward key, Start key and Stop key, Window selection key, and Escape key. The Start key is pressed several times when the KUKA robot required to run automatically. The rear view of KCP. At the back of KCP, there is rating plate, Start key and Enabling switch. The enabling switch must be pressed and held in order for the KUKA robot to operate. The Start key is pressed when KUKA robot required to run automatically. Exercise 1. Jogging of KUKA robot. There are two methods to jog the KUKA robot. The first method is the Cartesian jogging. The second method is the axis-specific jogging. In Cartesian jogging, the tool center point, TCP, is jogged in positive or negative direction along axis of coordinate system. Meanwhile, in axis-specific jogging, each axis can be moved individually in positive or negative direction. There are 4 types of coordinate system used when jogging the KUKA robot. The 4 types are as follows. Number 1. The World Coordination System. It is the root coordinate system for the root and base coordinate systems. The robot base is the default location for this coordinate system. Now, the KUKA robot is jogging by using the World Coordination System. Number 2. The root coordinate system. It defines the position of the robot relative to the world coordinate system. Now, the KUKA robot is jogging by using the root coordination system. Number 3. The base coordinate system. By default, this coordinate system is offset to the workpiece by the user. Now, the KUKA robot is jogging by using the base coordination system. Number 4. The tool coordinate system. By default, this coordinate system is offset to the tool center point by the user. Now, the KUKA robot is jogging by using the tool coordination system. Exercise 2. In-air program. There are basically two ways to program the KUKA robot. The first method is by C programming. The second method is by creating its template. The second method is usually used since this method is user-friendly and does not require an understanding in C language. The following display shows an example of implementing both Method 1 and Method 2 to program the KUKA robot. This is the section for the template. This is the section for the C programming. In this exercise, we will be using Method 2 to program the KUKA robot. Before starting with the programming of KUKA robot, a directory folder and file has to be created first. This is the process of creating the directory folder and file. After pressing the Enter button, the file is created and the KUKA robot is ready to be programmed. Running the develop program using step-by-step features. To make the KUKA robot operate, make sure that all S, I, and R icon are green in color. If any one of the icon is not green, the operation of the KUKA robot is immediately stopped. Running the develop program using running features. Make sure that all S, I, and R icon are green in color. Running the develop program using auto mode features.